Welcome back. So today I decided to explain this real-world application of linear inequality through this example. And this is a very actually a common question that shows up in accounting, in business, but in a very simplest form. So here it is. We got a fundraiser going on, and the volunteers from a hiking club decided to make hiking poles, and the fixed cost, minimum order cost, is 1,500 because they have to order parts and all that stuff to make the hiking poles and put the equipment or pieces together, plus the factory, the manufacturer charging them $10 per set of hiking poles. And each set of poles, they turn around and sell it for $40. We want to know what is the minimum number of set of poles that they need to sell so that the revenue that they make surpasses the cost. First, we need to identify and name what represents in an equation the number of hiking poles. So we call this x. So we say let x be the number of hiking poles. This is made and sold so that we have the same variable. The next thing we need to do, we need to come up with the cost function. Okay, and we can also call it cost equation. Let's call it C for cost. And what that means is very simply the initial cost, the fixed cost, we have 1,500. So even if you don't buy anything, you still have to pay the $1,500 plus for each set of poles we have to pay $10, and that would be 10 times x. Okay, so x is the number of poles and $10 for each cost. So this would be the total cost to buy however number of hiking poles we're going to buy. Now we need to come up with the revenue function. The revenue function is called R, and that's simply the cost of the price of each set of poles and times it by number of poles that is sold. So basically in this case we're selling that for $40 each, and whatever the number of the set of the poles that we're selling. All right, so we have two functions. We have a cost function right here, C equal to 1,500 plus 10x. By the way, you can actually rewrite it as 10x plus 1,500. It's the same thing. And so as the revenue function, which is 40x. We got two different functions. So now I need you to look at the last part right here. What minimum number of sets must be sold for the revenue to surpass the cost? To do this, so that means based on, so the revenue surpasses the cost, that means basically at what point R of x, the revenue function revenue, will exceed, that means it's greater than the cost function C of x. Okay, and when I said R of x, remember this is R of x and this is C of x, right? That's what that is. Okay, because the independent variable is x and the input value is x and the output is cost, and so is this one. The input is x, the number of poles that you're selling, you multiply $40 and you get the revenue. Okay, now if that's the case, we're going to rewrite this now. So let's rewrite it. Now Rx is, so we want to know 40x. When 40x is greater than 1,500 plus 10x. So now we're going to solve. this inequality, and then we're going to go from there. So let's start this. We are going to subtract 10x from both sides of the inequality. We get 30x greater than 1500. Very good. And then the next step is we're going to divide both sides by 30, 30, and in this case we will get x must be greater than, in this case, 50. Okay, now what is 50? 50 is the sets of 50 sets of poles. That is when once they once they sell over 50, that means 51, because it is a discrete number, not a continuous number, because you can't sell a half a pole, right? It comes with this as a set, so you can't sell one pole. You have to sell two of them because it's sets there. So once you sell 51, you start increasing or getting more revenue than the cost. All right. So very simply, this is one method. This is one method to solve this question, which is application, the real world application of linear inequality. Okay. Now I invite you to come back and look at the next video, in which I will go over the method 2, the second method solving this problem. But in this case, we will use graphing method. We will graph these two functions, and then we're going to do a graphing analysis. I hope you found this useful. Come again, and hope to see you in the next video.